bringing EVs to the market. That's a daunting task.
Ford's first invention was a two-cylinder engine that was mounted on the bottom of the seat here of a horse carriage. And the easy path was, let's just retrofit to the existing vehicle architecture. But if you really want to take advantage of internal combustion engines, you now need to change your vehicle architecture to create Model T with the two-box architecture. Today, as we move forward towards electrification and autonomy and smart mobility, we're seeing in the same inflection point where we have new propulsion system, but everybody is still using the same vehicle architecture. 85% of e-commerce is less than 5 pounds. And then when you look at these trucks, they are all made up of traditional vehicle architecture with big axles in between, big truck beds. That means very high off the ground. And when you add these couple steps up, multiplied by 150 to 200 steps, that's like 30 flights of stairs every single day. Why this traditional vehicle architecture? Because it's easier. So how do you look at this current dynamics and create value in the next generation of vehicles?
It's a little harder than that, right?
We literally reinvented the wheel.
Today's guest is Will Graylin, the founder and CEO of IndiGO Technologies. Will is rethinking vehicle architecture from the wheels up, literally. Through robotic smart wheels and flat floor EVs, he's building systems that solve the biggest friction points for fleets to evolve. Will, welcome to the show.
Thank you for having me, Chris.
What you guys have built is really interesting. It's kind of a different take on where EVs are going. Could you talk a little bit to sort of that vision, that you had for what you've built here?
We look at the world of transportation as going through this massive mega change and mega evolution towards electrification and autonomy and smart mobility. So instead of just looking at the hardware and say, hey, we're going to swap out a motor, for an engine, we're going to swap out the gas tank for a battery, and just, taking the same old architecture, we're rethinking, what does the customer ultimately need? Where is the hockey puck of transportation for last mile, particularly for communities? Where is it going? And when we think about that question, we then start to realize that we're doing something more than just electrification. We're rethinking about how we have better experiences in transportation for ordering rides, ordering products, ordering food, and how does a community transport, including, paratransport and non-emergency medical transport, and how do kids go around? Are we still talking about the big school buses that are going back and forth, and are we talking about big trucks coming in to deliver your packages one at a time? And how can we make it more efficient, more clean, more economically viable? So that's how we're looking at today, the transportation problem, to solve it as a unified smart mobility company. The exciting thing that we're seeing is by taking some new inventions that fundamentally changes the vehicle architecture, and we literally reinvented the wheel to create a new class of EVs and AVs that are really designed for next generation of transportation-as-a-service tasks. And just focusing on servicing communities, as well as all the transportation network companies and the merchants and businesses that are serving customers.
You sort of disaggregated the modern vehicle, and you kind of looked at it a different way. There's been a lot of challenges and barriers to bringing EVs to the market, right? And you're addressing a lot of those issues. I mean, can you talk about some of the key electrification issues that have been, traditionally a big challenge, and how you're kind of going at it?
Sure. I've been one of the earliest adopters of electrification as a consumer. And way back when the Chevy Volt was first, came out, the first hybrid electric, well before the Tesla. And of course, when Tesla Model S first came out, I was one of the earliest adopters. and a big champion. And it was great for customers like me who can afford an EV and have a garage that I can plug in easily. And it made perfect sense, right? I don't have to go to the gas station, and it's a better experience overall. Now, as you move forward to look at where transportation is going, the electrification and the autonomy of transport starts to face more and more challenges. So we focused on this growing trend of e-commerce, ride hail. And what we're seeing is that e-commerce companies that are delivering packages, they need to move from these big, heavy trucks that are delivering on average less than 1.1 packages per stop.
Wow. Yeah.
And 85% of e-commerce is less than 5 pounds. So you can imagine, here comes one truck with one brand that's delivering a sub 5 pound package to your door. Then another truck with another brand coming to your door with another sub 5 pound package. And you can see that the unit economics makes it harder to justify. And that trend is not slowing down. And then when you look at these trucks, they are all made up of traditional vehicle architecture with big axles in between, big, truck beds that you put the box on top of. That means very high off the ground, which makes it less stable in the first place. But also getting the packages into the vehicle and then getting the packages out of the vehicles, the driver has to go through a lot. When you have to take an extra couple steps, and when you add these couple steps up, multiplied by 150 to 200 steps, that's like 30 flights of stairs every single day. Multiply that by 300 some odd days a year. And then by the time these drivers get to 10, 15 years, they all have knee problems. Slip, trips, and falls are the number one injury issues that take them out of commission. And, it's very expensive, right, to do that. And not to mention, when you look at the gig economy workforce, that we're talking millions of gig economy workers. Most of them don't have homes like me to plug vehicles in, even if they can afford an EV. So they're mostly driving whatever used cars that they can afford, usually gas. 90 some odd percent of it is gas. And they're going out there and helping Amazon deliver for Amazon Flex or DoorDash or Uber or Lyft. And they're driving lots and lots of miles to get to the areas where they're working, and they never know where they're being sent to deliver packages or, where the rides are going to be concentrated. So a lot of deadhead miles, a lot of inefficiency. And even if they can afford to get EVs, charging becomes a problem. So how do you look at this current dynamics and create value in the next generation of vehicles that are more efficient, but not just the vehicles themselves? How do you bring in the charging for the fleets, whether it's large, medium, or small vehicles? Give them the right kind of compatibility and smart charging that's necessary to keep the fleets out there. And then how do you provide ultimately even services for the neighborhood, so you can aggregate not only the hardware, the software, the services, the repair, the maintenance, but also aggregate the drivers, so that not everybody's fighting over drivers and that are not economically viable, but recruit local drivers, screen them, train them, reduce the insurance costs. Because as you know, the other problems that you see with drivers, and Uber's telling this to us, as well as people on the fleet delivery side, which is you can't necessarily monitor and train them in such a way that you never know what the next Uber X vehicle is going to show up like, how clean it is, and whether they've been properly trained. And sometimes people who pick up the packages to deliver to your house, and if it's a nice, expensive package, the picture gets taken, but then the package sometimes goes with it. And the fraud is actually a real problem. So how do we create better quality experience with the right kind of vehicles, the right kind of monitoring, and also the right kind of software to manage the schedule, the peak demand, so that the vehicle utilization and the proper human utilization, labor utilization, that you train, the same vehicle could be repurposed for multiple applications. So we see that there is a demand for technology to be applied across the field, whether it's helping fleets serve their applications, or helping communities, create a transportation as a service loop, inside of that community to be more efficient, or helping companies that need, even small, medium-sized businesses, go electric by providing charging infrastructure that's smart, or vehicles that are smart, or a combination of both in a package that's smart and easy for them to use.
Managing a fleet of vehicles isn't just about keeping the wheels turning. It's about data, driver safety, cost efficiency, and most importantly, getting the job done without a hitch. That's where Element Fleet Management comes in. They help businesses from small teams to Fortune 500 companies make smarter decisions about their vehicles. Whether it's electrifying your fleet, cutting maintenance costs, or using advanced analytics to get ahead of issues, Element has the tools and people to make it happen. For more information, visit elementfleet.com today. More, proximity-based delivery kind of avenues would be really nice, because I get the Amazon truck comes through like 2 or 3 times a day. The UPS truck comes through like 2 or 3 times a day. You look in the back of some of these giant trucks and there's barely anything in them. But, you talk about the electrification of those fleets, which is already a really interesting thing. But, part of the challenge that I think we've seen so much in these fleets is like getting the electrification to where it needs to be, getting the charging infrastructure there as well. It's interesting to hear you talk about addressing that along with it. What is it that you're doing differently on that front?
So we'll separate the hardware from the vehicles, from the charging, and then ultimately, from how you provide smart mobility for communities so that you reduce, all the overlap. Those are 3 separate problems to
sure. I like to ask multi-part questions. I shouldn't do that, but I do. But yeah.
Well, it's a system level approach to think about how the entire system work. And when I was a nuclear submarine officer, and by the way, that's my submarine back there in the USS Florida.
Yeah, nothing complicated about that nuclear sub.
Well, that's a system, right? That's
for sure.
That's a system that's mission critical and that has to operate. There's nobody to rescue you if something fails. So you have to think about everything from power generation. We did our nuclear power. We generate our own electricity. We make our own water, make our own oxygen, and even scrub our own carbon dioxide so that we don't have to resurface like the old World War II days. So as a system, when you think about it systemically, then you can optimize for how should that system really work? So when I look at electrification and we look at how systems of transportation work within the nation and then within a specific community, that community downtown Boston could be very different than the suburb of Boston or
Sure.
San Francisco or New York.
Or rural area.
Yeah. So how do you make a system that works for that geography, that ODD, operational design domain? People have been talking about autonomy. Well, autonomy is going to take stages. It's not going to be as easy. And people like Waymo have proven the ODDs that work in very specific areas like San Francisco, Austin, and Arizona. But when you're talking about so much geography to take care of, how do you now treat those ODDs as systems themselves? And what kind of vehicles, what kind of charging infrastructure, what kind of labor, and how do you aggregate and make it efficient within that ODD or that loop? And we'll call these go loops. So I can start with the vehicle side. Right now, I think our original mission at IndiGO Tech started with the discovery and reinvention of this wheel called smart wheels by Professor Ian Hunter out of MIT. So after I graduated from MIT, I became a tech entrepreneur and started 4 previous companies that were all acquired and made it into the mass commercialization space. The last one being Samsung Pay that acquired my company that called LoopPay. And we turned it into Samsung Pay to compete against Apple Pay. But currently, when I participated with IndiGO Tech, it started out as literally an invention of smart wheels. And I'm happy to show you some pictures of what the smart wheel looks like.
We'll run some videos here of like the smart wheel in action.
Yeah, and then you can show your audience what that looks like. But essentially, hub motors are not new. They've been around since the late 1800s. And hub motors basically are a stator and a rotor attached to the wheel itself. And it's actually very popular today in electric bicycles, electric scooters, electric skateboards. So why is it that it's not really popular in electric vehicles? And the primary reason is it hasn't solved the fundamentals of physics problem called the unsprung mass problem. So in other words, every pound of mass you add to the wheel to make the wheel go, you have to add 10 more pounds to the body, the other sprung mass. So this is the unsprung mass, the wheel. So the sprung mass coupled by, spring in between has to have 10 times more mass in order to have the right type of safety and the right type of comfort. Otherwise, you either have a bouncy golf cart feel or unstable feel. So long and the short of it is that we created a robotic smart wheel that have 2 stators, 1 rotor, and the 2 stators can actually move in opposite direction with one another and attach to linkages to the suspension to effectively move the wheel up and down, controlled by a computer that has sensors that detect the motion to keep the vehicle ultra stable and safe, and then very smooth when we're going over bumps or turning corners. So that allows us to solve the sprung mass to unsprung mass ratio physics problem to be able to not only free up all that space in between the wheels. Now you have not only more space in between the wheels, you can have a low flat floor that makes it easy to get in and get out and save you from having to take multiple steps to get onto a platform, whether it's a bus or whether it's a truck. So that fundamentally changes the vehicle architecture. You can make the vehicle lighter. Lighter means a smaller battery, which is the most expensive part. And smaller battery makes it even lighter and even more faster to charge. So that is a fundamental shift in a vehicle architecture that previously just was not possible with existing propulsion systems and suspension systems.
The other thing I'd like about it, and out of the minds of MIT here, there's sort of discrete components too. When you look at sort of part counts, I can see the wheel is sort of like just one part you stick in, something goes bad, you pull it out and stick a new one in there, kind of thing. I mean, is that literally how it all works?
Yeah, you can think about it in that way. Think about it, discrete components. We now have 4 corners and gives us 5 degrees of freedom for the vehicle, much more control. So that means roll control, pitch control, yaw control, bump control. And you have a direct drive coupled to the wheel. You don't have all these excess components that takes up space in between the wheel, like motors, reduction gears, transmission, drive shaft, CV joints, all of these different components. And you have redundancy. So in other words, you have, if one wheel fails, you have 3/4 of your power still to get you there. And if you have 2 wheels fail, maybe you still have 2 more wheels to get you there. But it's also very easy to repair. And changing tires is still the same. So there's no difference when it comes to, bolting on and bolting off. If you get a flat, you just change your tires exact same way. And the brake calipers are, essentially the same place. But with direct drive, you also get better regenerative braking, more efficiency in transmitting the power. So there are advantages and disadvantages. But essentially, when you think about it, instead of having two big motors in between two sets of wheels, we have four small motors that, from a cost perspective, it's almost the same when you're at scale. Maybe a little bit more expensive because you have four discrete components, but you're also saving a lot of other components like drive shafts and CV joints. And because you can reduce the weight of the vehicle, here's where the savings come. You have a much lighter weight vehicle. In a lighter weight vehicle, where is the most expensive part? It's the battery. So if you can save on the battery, that is actually much, much better.
Yeah, and the battery seems to be the hard part. You know, out of curiosity, I mean, you talk about, you know, you lose one wheel, you can still run with the three wheels. I mean, could you run this in like two-wheel drive to, you know, like extend your battery life and only use four-wheel drive where you need it?
Yeah, you can now use the smarts of your VCU and your computer system to turn on and turn off each wheel as needed. So imagine you making a left-hand turn. If you're making a left-hand turn, well, that right outer wheel should be spinning, but your left inner view, you can just leave it freewheel. Why put energy into areas where you don't need to? And believe it or not, when you can program each wheel independently, you can actually save energy over time, make it more efficient.
Yeah. Well, and you don't need a differential in it either, right? I mean, because that's the thing. When you are taking a turn, one wheel's moving faster than the other.
That's right.
So you have to account for that. Otherwise, I would imagine, you know, your tires are going to go bald pretty quick. But I mean, but you bring that to market, which is kind of interesting. Without it, you replicate the functionality of a differential without a differential. Right.
Exactly. You have four independent wheels that are independently programmable. And more than that, you have four independent suspensions that is independently programmable, all with a central computer system. And so you can keep your stability when you're turning. You don't have to roll every time that you're turning, also to reduce motion sickness and to create a smoother, safer ride.
Oh man, my family would be all about reducing motion sickness. My daughter always complains. She's like, "You're making me sick while you drive."
Well, that's the beauty of this kind of a drive system. We're not trying to go and compete against the Teslas or the BYDs and trying to go 0 to 60 in 2.6 seconds. In fact, no Uber customer wants their vehicles to be going 0 to 60 very fast. In fact, just give me a smooth, comfortable ride and a roomy ride. And when you see some of the pictures of our vehicles, how much space it is, how easy it is to get in and get out. And also, with nothing in between the wheels, it's ideal for us to be able to facilitate wheelchair access. So naturally, we can facilitate wheelchair access without needing a lift kit. If you ever see those lift kits, right, they rip out the floor. Yeah. And it's very expensive. It eats up interior space. Well, ours automatically comes with a wheelchair accessible vehicle. Every seat is on rails. It's a low flat floor, right? You got no axle in between. So it makes it so much easier as a vehicle architecture.
You mentioned that you can get a wheelchair into these vehicles without even, needing a ramp, essentially, because they're like, you can get them curb height. Mm-hmm. But on the same note, like you talk about like loading packages in and just like, being able to push a cart right onto it. I would imagine if there's some like height differential, you could also lift it up too, to meet that demand. I think how much play do you have in all of that?
We have the ability to go up 100 millimeters and go down 100 millimeters, assuming that you're in neutral position. Mm-hmm. So when we tune for the GVWR, we're trying to tune for what the average space is. And we're also still have a passive component. So you don't have to, use active all the time. So when you turn on active, that allows you to then work with the passive suspension to create better stability and to create better comfort. And of course, being able to lower and raise dynamically at millisecond levels, up and down, close to 100 millimeters. Obviously, the frequency is going to limit the amount of distance traveled, right? So,
Right.
but with pure electromagnetic using electric motor, we have the fastest response time. We don't even have to have a hydraulic cycle, to have a motor spin up a hydraulic to go up and down.
That's pretty neat. You started with an invention, and sort of the original idea is that like, we're going to build this invention and we're going to put it out on the market and everybody's going to want it and put it into their vehicles, right? But it's a little harder than that, right? Can you talk about the challenges of creating a new technology and popularizing it?
If you're in a steady state environment and you have a better widget and there's already a market for that vehicle, it doesn't require a lot of change. If it's a straight replacement, then that kind of a model, I got a better mousetrap, that's easier to get into the existing distribution system.
Yeah.
But we're kind of in this inflection point of massive change. And this kind of an invention and reinventing the wheel requires.
I love being able to say that and mean it. Reinventing the wheel.
Yeah, it's nice to be able to say it and mean it.
It's not just
You're
a
right.
cliche anymore.
That's right. Yeah. That's right. But when we're reinventing the wheel, we really want to reinvent the vehicle architecture too. And that one is harder for existing OEMs to make that shift and that change because nobody else is doing it, and them being the first is much more difficult. There's an old saying in Chinese that says, who's going to be the first to eat crab, right? Nobody wants to be first. But once somebody has, cooked up a delicious food and nobody's dying from eating crab, then it makes it easier. So what it turns out was we initially had this naive notion that, we just proved that the technology works. And of course, the OEMs are going to adopt this, not fully realizing that for an OEM to make any kind of change is actually much more difficult. Most of the existing OEMs are not willing to make that kind of architecture change. A big company, there are so many ways to say no. You can have 99 yeses, but just one no to stop the entire project. So if we were to wait for them, meaning, existing OEMs to take the lead, we may wait until we ran out of cash and never really make it into the marketplace. So I took over the company in 2020 to see this invention through, to make it through the valley of shadow of death, to make it to the innovation stage. Because there's so many inventions that can die along this path. And what's required to get to the innovation stage to make an impact in society is that we have to very carefully aim and take the attributes of this new invention to say, where can we apply it? How do we create not only better user experience, but also better unit economics? That becomes, the two E's, I call it. I was a double E major in undergrad and grad school at MIT, which stood for electrical engineering. But my ongoing degree, in entrepreneurship is about the two E's of experience and economics. So if we can address those for our customers, then we're talking about creating value.
Managing a fleet can feel overwhelming, but not when you have Element Fleet Management on your side. From maintenance and fuel to data analytics and electric vehicle transitions, Element helps businesses keep their fleets efficient, cost-effective, and ready for anything. With decades of industry expertise and cutting-edge technology, they simplify the complex so you can focus on what you do best, running your business. Ready to take your fleet to the next level? Visit elementfleet.com today. So walk me through this though, because you start off and you've got a cool invention you want to bring to market. And now all of a sudden you kind of have signed up for, building a whole car. And if somebody told me, hey, you got to go build a whole car. And I, just looking at the amount of parts in a car, that's a daunting task. One of the things that's really interesting about what you've done is, you're taking on a very specific market with sort of the last mile delivery and ride share, which kind of allows you to focus on a very specific set of use cases, I think, too, which is helpful. How'd that all play out?
Well, necessity is the mother of invention.
It sure is.
And if Elon Musk didn't go down the vertical path, then it would have been hard for him to have pulled off Tesla.
For sure.
And I would say the same for Henry Ford. Frankly, I'll show you a picture real quick of Henry Ford's first entry, I would say, into this world. The Ford quadricycle. Ford's first invention was a 2-cylinder engine that was mounted on the bottom of the seat here of a horse carriage. And the easy path was, hey, let's just retrofit to the existing vehicle architecture. And by the way, there were mega players in the horse carriage business, right? Back at those days, the equivalents of the big players of today. And of course, it would have been easier to adopt to their vehicle architecture because that's what they know what to do. But if you really want to take advantage of horsepower and the power of internal combustion engines, you now need to change your vehicle architecture to create the Model T with the 2-box architecture. In other words, you need a much bigger engine that is in the front, first box, and then the passenger and the people on the second box, right? That's new architecture. Ford just said, you know what, screw it. We are going to develop it. We're going to put together the pieces. We're going to vertically integrate, and the rest is history. Well, today, as we move forward, we're seeing in the same inflection point where we have, new propulsion system compared to the old one, but everybody is still using the same vehicle architecture. Well, we don't have a big engine in the front anymore. Why do we need a big bonnet? I was speaking with Doug McMillon, the CEO of Walmart, and I said, you have a Model S, I have a Model S. I said, when was the last time you used the frunk? He says, never.
Yeah.
And I said, I've used it once. So why this, traditional vehicle architecture? Because it's easier, right? Because it's easier. And so we have an opportunity to change this vehicle architecture. We don't need to have, such high floors, And when you look at how many steps it takes to get into an existing vehicle, even this Rivian vehicle that you see here on the top left, it takes 4 steps to get in, because in between there's this axles and chassis that's designed for the traditional vehicle architecture. So if we go to the smart wheel technology, we have a much better way of, delivering a solution. The low flat floor vehicle architecture, it makes more sense than what's, currently existing out there.
Yeah, I had to pick up some furniture the other day from a store, and man, I could have used that. I could have just slid it right in.
Yeah, so this is kind of a so instead of close to 800 millimeters to get in, we're talking closer to 400 some odd millimeters, and that's a big difference.
Well, you could potentially add more carrying capacity to it, I would imagine, as well.
Oh, sure. Overall lighter, overall more efficient, more aerodynamic.
You could really make a smaller vehicle that holds more.
Yes, precisely.
When you start to add up all the economies of this, there's a lot of pieces here where you start to save money, energy, all those things. Obviously, you don't have a whole fleet of these out on the road, but I mean, how much better are the economics of this than, sort of what we've got today?
So the better economics really comes in a combination of factors. You can build these in various sizes. And as you rightly pointed out, for the same vehicle size, you can have more space, or for the same space, you can have a lighter weight vehicle that has a smaller battery. So not only can you be more cost effective on the upfront cost, but think about the cost when it's associated with better user experience, less injuries, less worker comp.
Less maintenance, I would imagine, too.
Yep. Less injuries, and being able to do more, whereas previous vehicles can't necessarily, facilitate the, you have to add an extra, lift kit for wheelchair access, for example. So the cost savings is a multitude when you look at what is the total cost per mile, and what is the total cost per package delivered.
So if you were talking to like fleet managers, what should they, like if they're starting to evaluate new platforms, like what kinds of things would you recommend that they start looking for? I mean, we talked about like a lot of the cost dynamics of this and sort of like user experience and some of the, employee safety issues and things like that. I mean, but like what kind of questions should the fleet managers be asking when they start going down this road?
So for a fleet, when you look at the size of vehicle, number one is what is the right vehicle for your fleet? What is the range that you're trying to accomplish? And are you setting yourself up for not only electrification, but also for autonomy? And we're looking out into the future, and we know that these vehicles have to be smart. So we're building a variety of sizes from small to medium to large and even micro and manned or unmanned. And our vehicles have the ability for center driving seat that allows us to have drive-by wires so that it'll be ready for autonomy when the time comes for autonomy. And so this center driving seat that you see here basically allows for you to get out on the left or the right, whichever side is safer, and one skew for the whole world. Rather, you don't care whether it's US or UK, Hong Kong or China. And then that center driving seat can also turn 180 degrees in seconds for you to, be human driven for one portion of the day. And if it's ready for autonomy, you can always turn it around. And that provides a level of utility that a fleet, depending on what they're looking to do, whether you're delivering people or delivering packages, we want to give a host of options to create a new class of vehicles that are going to be driven and powered by this new vehicle architecture and these new smart wheels, and making sure that they have the right size vehicle for the right job. How many miles are they going to operate in a given day, and don't oversize that battery. But the other thing, Chris, is charging. So we acquired EverCharge earlier this year because we invented the smart wheels, but they invented smart power. And that smart power technology that they have invented with a bunch of patents allows for the same amount of power that's available to the site to have 5 times or 6 times more charging cells so that we can level up and give the fleet more ability to charge more vehicles so that overnight they'll be all charged up rather than having limited number of chargers, and not only have smart load balancing and smart power charging, but also smart rules so that they're only charging at the most cost-effective time if they wanted to reduce their costs, per mile. And that is something that we're bringing to the fleets. Now, the last piece is compatibility of the vehicles with the charging. A lot of times, people don't think about what the onboard charger of the vehicle looks like, and one line of code that's not right means that your vehicle is not properly charging, and you want there to be full compatibility between charger and vehicle, and that's something that we take pride in as well, to integrate vehicle development and charging development and customer service at the same time.
The one thing I hear from fleet managers is the charging infrastructure around EVs is really an impediment for them. And you're making much better utilization of those pieces of infrastructure, right?
Absolutely. Charging can be either a barrier or an enabler. And right now, they're mostly a barrier because, those who are driving, whether you are a 1099 or whether you are a W-2, if you don't take care of the charging infrastructure, and if you don't take care of enabling the same amount of power that's existing to be distributed and allow vehicles to be properly charged, and that becomes a total barrier for vehicles to get electrified. Never mind to get towards some level of autonomy, level 2 ADAS to level 4 ADS.
One of the big criticisms of modern vehicles, and particularly I think this centers on the United States, is sort of we've gotten into these bigger and bigger vehicles with taller and taller with these giant hoods in front of us. And, one of the things we talk about a lot is occupant safety. But one thing that I think doesn't get enough conversation is pedestrian safety. And, you're showing me a picture there of a vehicle where you had absolute visibility out the front. You didn't have this big, long hood there, like that obscures the view. And I saw this one picture where they put 15 kids in front of like one of these taller vehicles, and you couldn't see any of them
right
from the driver's seat.
Right.
This kind of changes that paradigm. I mean, one, you have the potential ability to create sort of lighter vehicles, which helps, but you also have the ability to improve visibility and improve sort of that. And when you're talking about rideshare and last mile delivery, that's a big deal because that's a big concern on those kinds of vehicles, right?
Absolutely. When we can lower the center of gravity of the entire vehicle and lower that floor because you no longer have a tall vehicle. By the way, those tall vehicles, stability-wise, you've seen videos of people trying to swerve to avoid accidents, and they're so top-heavy that not only do you have to climb up to get to your driver's seat and climb up and down, but you can easily have rollover accidents. So if we can provide more safety for the vehicle itself, lower center of gravity, more fuel efficiency, and better visibility. And, when you're talking about, it feels like a car, right? When you're driving, as opposed to, you're in a big truck. I think all of that adds to safety. And the way that we're further looking at community delivery of people and packages, well, we say, why not reduce the deadhead miles and create community local electric transport services, for these communities with smaller vehicles for the last mile?
Yeah.
Why have these big trucks going into neighborhoods, delivering one package at a time?
And it's hard I know in my neighborhood, I've got kind of a very, we've got one-way, narrow, kind of more urban streets, and it's difficult for those vehicles to navigate. And then if they got to pull over and deliver something, then traffic's backed up and people are honking, and it becomes an issue. And having, I like what you're saying about the right size of the vehicle for the job. That I find to be quite appealing, and I got to imagine the economics of that, support that as well.
Absolutely, it has to be supported by economics. Not just incentives, but literally, it should be better than the previous generation.
Do you see fleets investing in individual vehicles, or do you envision them kind of taking these on as sort of like a different ownership model and a different we talked about that last mile delivery and people in their sort of personal vehicles and things like that. And then if we start to localize these more into neighborhoods with sort of, I imagine, kind of smart charging hubs for these vehicles and the ability for people to get in these and drive them around. I mean, how do you envision that ownership, model plays out?
So let's separate those into large fleets that are company-owned assets, independent service provider assets, smaller, medium-sized fleets, and then transportation network companies that want to leverage the gig economy workforce within the communities. Let's separate those into those pools. For the large fleets, number one, we have the best level 2 charging infrastructure, and we're the OEM. We manufacture, we design, we're responsible for the software and the patented capabilities. So we're one throat to choke on the charging side. So if you're a large fleet, you need the right charging infrastructure, and we can help you scale from whether you just want 2 stalls and all the way up to 200 stalls. We can help you set up the right smart charging capability. So if you already are experimenting and using some larger trucks like Harbinger or Workhorse or whatever you're using, we can help you with level 2 charging. We can help you with level 3 charging to supplement the level 2. And so you need to have charging. If you don't have charging, it's like no gas station. So don't even bother with the vehicle. Two is identifying the right kind of vehicles that work for you right now, and then ease into the electrification. Start with replacing the old gas vehicles and experiment with the routes that says those routes that are within the range of this vehicle, let's try it. And we already have customers like ours, like Pepsi, UPS, Avis. We see case studies that they have where, for their electrification project, they can save 40% over the course of 3 years, which is, massive, wow. Right? And so the next step is thinking about the future of what kind of vehicles do you need to fulfill those needs, and think about not only the existing vehicles that are on the road, but some of the vehicles that we're developing. And as we're developing these, we're getting requirements from some of these large fleets to help us plan for the future, because nobody is rolling out, turning on electrification, in a step function. They're going to gradually ease into it. So recommendation is there. The second part is, if you're a fleet that still uses independent service providers, the low-hanging fruit is to set up some of these stalls in electrification and wait for them to bring their own vehicles and provide the charging infrastructure, because that makes it easier for them. And if it makes it easier for them, they provide, lower costs for you per package, or per mile delivered. So again, charging infrastructure is key. Now, as we move forward to some of the smaller, medium-sized businesses, you may have a smaller fleets, more distributed. Now, some of the Class 2 vehicles starts to make sense. And in those cases, we may be able to even bundle what's called an EASE program, Electrification-as-a-Service. We'll help you just set up your charging. We'll help you bring a vehicle. We'll finance the entire package, and you just pay a monthly fee that's going to be less than what you currently pay. So that's a great way to package and bundle charging, vehicle financing, maintenance, electricity. If you bundle it all together, what do the smaller fleets want? They just want to go and do their jobs, make money. So if we can make it easy, so that's the EASE package. And then as we move forward to thinking about how do you treat last mile delivery of people, packages, and food, that's where mixed tech forward managed fleets, where GoLoop is, we're creating a GoLoop service as we work with companies like Uber and FedEx and others. FedEx, as you know, is an investor of ours, and Foxconn's an investor of ours, SK is an investor of ours. And we're basically seeing that, hey, if we can service this community and we have the right kind of vehicles for the community, and we do the charging, the parking, the maintenance, the repair, the electricity, and then one-stop shop. And then we hire drivers, we train them for, whether it's delivering people or delivering packages or delivering, whatever it is. We then create a service for the community, and we monitor these drivers. We train them, and we ensure quality of the experience. And that makes it better for the community, makes it better for the drivers. They get paid fairly, and they don't have to worry about depreciation of their vehicles and tearing their hair out, and cars in the shop, and they can't make money. But they can still have the flexible hours if we do it the right way by creating these gigs and shifts. So that becomes transportation as a service. So those are step-by-steps of how we look at engaging the next, generation of smart mobility.
That's a great vision. Very cool. But the one thing, I love the smart wheel, amazing tech, but man, those when you start talking about like all the charging stuff, as somebody who owns an electric vehicle, man, I would love to have, because I go to like, say, the mall where they have a charger, and I got to wait in line for that person to get off that charger. And that person might have gone shopping for an hour, and it's just, I'll just pay, the whatever, 10 cents a minute or whatever it is to, but I love the idea of like a smart stall where you could just pull your car in, start, like plug it in. You may not get the power right away, but at least you're there. And the second that charger's, that power is available, it starts charging your vehicle, and you can just leave it there for a while because you got enough, concurrency there to deal with it in a much more efficient way. So, boy, I know you don't do consumer market stuff, but I am ready for it.
Well, eventually we love to get to a point where our flow vehicles, make it out there into the consumer space. Right now, we're focused on fleets, and if we can do it well for fleets, I'm sure the consumer side can benefit as well.
That's the right way to go, but on a personal level, if you could just start installing these all over, like in the areas I go, that'd be great. This has been a really interesting conversation, and I gotta say, Will, thanks so much for being on. It's been a really cool conversation. It's really interesting tech, and I think when you dig into, the benefits that this brings, it's a really compelling story, and I think your overall vision is a really interesting one, because I do think fleet managers would love to just not have to deal with 20, 30 different vendors, but kind of, more consolidate along, like somebody who's going to give them a lot more of it all in one, tidy package that's easy to own and manage.
Well, I'll just add, Chris, that for fleet managers, our goal is to build strong relationships to help them with their business. At the end of the day, if we can help them reduce their cost per mile, provide reliability, their total cost of ownership, and how their drivers really feel and have less injuries, better experience for their customers and their drivers, that's what we're all about. And you can see that, we are a creative thinker that is very customer focused, and we love building relationship with fleets. And this is why I just came back from Dallas 2 days ago with one of our customers, with Frito-Lay's and Pepsi, and we love talking to our customers and just trying to figure out how we can better help them. And one of the ways that we figured out how to help them was they have these peak energy demands, and we said, okay, well, let's go back and we did a bunch of coding. We said, okay, here's what we're going to do for you. We're going to ramp down your charging from 3 p.m. and then get down to practically nothing in your peak hours, and then ramp it up again by 9 p.m. and 11 a.m. or 11 p.m. We're fully charging, and we're saving you a huge amount of money on your electricity bill, and we're allowing all your vehicles to be plugged in
charged as efficiently and fast as you can.
Yep. And by the morning, everybody is topped up and ready to go. So we want to build relationships with fleets. That's the bottom line. And we treat them as, our, precious customers. And sometimes we'll discover problems that nobody even knew. Like, for example, another big customer of ours, they bought a bunch of these trucks that their onboard charger had, one compatibility issue that they didn't even know. And we detected it from our charging side. And we had to share with them, and they upgraded the code, and then we made it compatible. So then we can have their vehicles much more functional. So when we treat them as really valuable customers that just trying to help them solve the problem of electrification. And also many of them are thinking about autonomy going forward, right? So we want to be partners with them for the long run. It's not just, let me sell you a vehicle or let me sell you some chargers and goodbye, right?
Yeah. Well, so if people want to find you, where should they go?
They can go to indigotech.com. And my direct email is, I'm very open, will@indigotech.com if somebody really wants to reach me. I'm also on LinkedIn.
Careful what you ask for.
And I'll direct them to the right places, and I'm happy to help. Look, we're very customer focused, and it's a journey, right? Transitioning to the next phase of transportation is a journey, and we're here to help.
Well, that sounds like an awesome journey. Thanks so much for being on. Keep up the good work. I'm excited to see where you guys go and what you bring to market. It's going to be an interesting new world we're stepping into.
Thank you, Chris.